Hello, it's time to do our double replacement lab. I'm not sure how long I can take myself seriously with this hot dog on my head, but I'm going to try. Double replacement lab is our next lab up. The beginning question is, what type of compounds containing polyatomic ions always form precipitates? What is the common characteristic of all colorful compounds? Those are the two questions we're going to be trying to answer. The first thing we need to do is, of course, write our title. A lot of people are leaving the title out. You need to have the title in there. And then I need you to write your beginning question. After you've done that, I have a couple definitions I want you to define. First of all, let's define what a double replacement reaction is. A double replacement reaction is when you have two ionic compounds and the cations and anions switch. So imagine for a moment, got a stuffy nose, I don't know why, a compound with A as the cation, B as the anion, and a second compound with C as the cation and D as the anion combining. Cation A now combines with anion D, and cation C now combines with anion B. Now, these have to be dissolved in water. But in order for there to actually be a reaction, one of them has to form a precipitate. A precipitate is when you get a solid formed. It will look cloudy. So one of these two compounds will form a solid. The other one will not. It will stay dissolved in water. Okay, we will be discussing what type of compounds tend to form solids, which means they're insoluble. So we're going to write that down. We're going to write down soluble, which means it dissolves. We're going to write down insoluble, does not dissolve. I'm going to turn the TV down, hang on. And then precipitate. You know that we call rain and snow precipitation because it comes from the sky. The sky, of course, is a gas. Air is gas, and precipitation is when you have a solid or a liquid that comes out of it because it can't hold it any longer. So in our case with solutions, you're going to have a solid that materializes. IALIZES from a solution. All right. Now, okay, time for our procedure. Step 1, you're going to put your safety glasses on. Step 2, you need to get a reaction sheet. This is a laminated sheet. With a grid on it that looks something like this. Step 3, in the grid, you will take your dropper and you will put a drop. The grid starts out here. The grid starts out with sodium hydroxide in the first row. So you'll take your pipette that is labeled sodium hydroxide and you'll put a drop of it into each column or each box on the grid. When you're doing this, make sure that the pipette does not touch the tip of the droplet. Just drop it onto the bottom without it touching the paper. Okay, after you've done sodium hydroxide across, then you'll do iron 3 chloride, and so on. Step 4, you'll be repeating, only this time you'll be using the compounds that come across the top. The first one is sodium phosphate. So you'll put a drop there. The next one is copper 2 sulfate. And so on and so forth. So you'll put sodium phosphate all the way down the first column, and then copper 2 sulfate all the way down the second column, and so on and so forth. Once again, be sure not to touch the tip of the pipette to the liquid. Step 5, you're going to observe the drops and look for a precipitate. The precipitate will be cloudy compared to the dark background in the grid. If you find one, you'll write PPT in the box. Okay? Make sure you copy the data table into your notebook as part of your pre-lab. There's the data table. Make sure you copy that into your data table. And then after you are done, you're going to write reactions for each one of the precipitates. For instance, if you had a precipitate form in number 2, if you had a precipitate form in box 2, you're going to write 2. In box 2 is copper 2 sulfate and sodium hydroxide. React to form copper 2 hydroxide. Oops, I'm running out of room. And sodium sulfate. Okay, now, one of these is a solid and one's not. That's going to be part of our post lab to figure out which one is solid and which one is not. Okay, so we'll pick this up after you guys have finished the lab and start putting those reactions down.